It's a two-tailed test, since our alternative hypothesis is that the probability is not 0.45. So we're concerned with the probability being either greater or less than 0.45. And consequently, the significance level is shared between the two cases. My strong advice is to draw a quick diagram so you can visualize the interval. There can be between 0 and 15 successes. Now, calculations involving the lower tail are pretty straightforward. We are seeking the largest value where the probability in this interval is strictly less than 2.5%. In other words, the last value in the critical region is the largest value where the probability is strictly less than 2.5%.
We'll select menu. We'll go to option 7, distribution. We'll then scroll down and get the binomial cumulative distribution, and then we'll select variable. Now, in our experiment there are 15 trials and the probability of success is 0.45. And remember, the lower tail, we're looking for the largest value where the probability is less than 2.5%. So let's try 1, or the random variable of 1, which means up to and including 1 successes. And this is certainly less than 2.5%, but is it the largest value where the probability is less than 2.5%? Well, we'll try up to and including 2 successes, and this again is less than 2.5%, so we ask ourselves the same question: is it the largest value that is less than 2.5%? Well, yeah, up to and including 3 successes is 4%, so this doesn't qualify. So the largest value where the probability is less than 2.5% was up to and including 2 successes.
And so we can see the last value in the critical region with a probability strictly less than 2.5% is 2, up to and including 2 successes. It's the upper tail where things can start to get messy for students. We want to find the smallest value in the critical region where the probability in this interval is less than 2.5%. But we can't do this directly because of the way cumulative distribution tables work. However, we can simply reframe the question. What we can ask is, what is the smallest value for which the probability is greater than or equal to 97.5%? And before you move on, you should be convinced this will give you the last value in the non-critical region.
And we're looking for the smallest value where the probability is greater than or equal to 97.5%. So let's try up to and including 12 successes. Yes, this is certainly greater than or equal to 97.5%, but is it the smallest value? Well, we'll try 11, and this too is greater than or equal to 97.5%. So again, we're asking ourselves the same question. Is this the smallest value? Well, we'll try up to and including 10 successes. This doesn't qualify. Whilst it's close, this isn't greater than or equal to 97.5%. So we do know that the smallest value where the probability is greater than or equal to 97.5% is up to and including 11 successes.
And we can see from our calculator that the smallest value in the non-critical region is 11. And consequently, the first value in the critical region will be 12. So to summarise, step 1, draw a diagram. Step 2, using your calculator, find the largest value where the probability is less than 2.5%. And this will be the largest value in the critical region. Step 3, using your calculator, find the smallest value where the probability is greater than or equal to 97.5%, and this will be the last value in the non-critical region. And there we have it. Not difficult, but you have to get steps 2 and 3 exactly right. so that you get the critical regions exactly right. And it will be no surprise to you that the questions are contrived such that if you make a mistake, you'll go the other side of the critical region. In other words, the question is designed so there's no margin of error. If you get it wrong, then you'll definitely get the whole answer wrong.